Math is also a subject where you have to read things carefully. So this question says the graph of y equals 1 over negative 2x squared minus 0.5, which, when you see that equation, your head should have no graph. You'd be like, I have no idea what that looks like. Okay? Was reflected in the x-axis, and its image is shown. So this graph is not this equation. I'm going to put a blue box around this equation, and if this equation was reflected in the x-axis, that's a vertical reflection. Does it make sense that this original graph would have looked like this? That is the equation that we're given, but we are so used to when there's a graph and an equation, 99% of the time they match up, right? So we have to be careful when we read things that we don't, our brain will be like, oh, it's always the graph that's given to us. We make that assumption. We have to be careful with that. Now, we need to come up with the equation of the red graph. So reflected in the x-axis, this is where having that ability to switch things back and forth, reflected in the x-axis, that is a vertical reflection. That means my y values are changing. That would mean that if I wrote this in function notation, that the negative would be outside in front of the function. So we see how all these different representations are going to be really important, because now to write this equation of the new red one, all I have to do is I have to take the old equation, which was this, and put a negative in front. That's what this notation y equals negative f of x means. It says take your original function and just put a negative in front. That's what algebraically is happening. And now I'm going to test some of your algebra skills. I'm going to say, let's pretend this question was multiple choice. And I'm going to give you 3 options, and you have to tell me whether all 3 are right. Maybe all 3 are wrong. It's one of those multiple choice where they give you 3 options, and they say A and B only, A, B, and all are right, all are wrong, and so on. So here are our options color-coded. Option A, okay? Option A, they write this as y equals negative 1 over negative 2x squared minus 0.5. Option B, black, they write this as negative 1 over positive 2x squared plus 0.5. And option C, in green, they write this as y equals 1 over 2x squared plus 0.5. Can I take the red, which is right, can I take the red, which is right, and change it to any one of these? Do I change it to the blue? Do I change it to the green? Do I change it to the black? Are all 3 of them right? Are all 3 of them wrong? Is only 1 right? Or is there 2 right? We are going to find out. And the reason I do this is because this is a very common arithmetic error that students make. And if you make the error, you'll want to see it now to fix it up so you don't do it when you have to write a quiz or a test. Okay, so in your head, Don't say it out loud. I want you to select, because my job is not to be like, who picks the green one? And they put up their hand, ha, you're wrong. No, that's not. But we want to find out, in your head, you want to find out if you're making a mistake or not. Or you want to find out if you've got it completely right. If I had to simplify that negative outside, which one's right, which one's wrong? Are they all right? Are they all wrong? Okay? So you made your decision. Okay. So we will discuss the blue one is correct. The black one is wrong. And the green one is correct. So, what happened? Why do these work? How can we think about this to make sure that we understand what's happening? Now, a negative outside of the brackets here is like a negative 1 outside the brackets. And a negative 1 outside the brackets, I could write as negative 1 over 1 as a fraction. Because how do you multiply fractions? You can multiply the tops and multiply the bottoms. So for the blue one, I thought of that negative outside the bracket as a negative 1 on the top and a positive 1 on the bottom, because this would still be negative 1. And if I multiplied the bottom by 1, it would stay the same. If I multiplied the top by negative 1, it would become negative 1. So the blue one is right. What's wrong with the black one is your brain connects another mathematical idea with this mathematical idea. You saw the negative out front and you wanted to distribute. And you distributed the negative to the top and the negative to the bottom. But doing that actually meant that you were multiplying the top by negative 1 and the bottom by negative 1. And negative 1 divided by negative 1 is positive 1. And that's a different thing that we started with. So, of course, the green one, and this was the idea, if you chose the black one, this is the idea that you were kind of thinking of, is you were thinking about distributing. When you multiply something outside brackets and you have more terms inside, like in the green one, I distributed the negative to the negative 2x squared and to the negative 0.5, making them both positive. And the top would just be 1 by 1, make it impossible together. Of the 3 correct ones, right, because technically, the red, the blue, and the green are all correct. If you were writing this on a test, I would suggest the red, because it's the easiest, right? The negative's outside the function, we write it outside the function. As far as, you know, if you were going for a job interview, the red one is like, kind of like you're a little sloppy. You haven't done yourself up quite right. Haven't washed your hair for 3 weeks or something. Not the best idea for the job interview. And so these ones are more cleaned up. The green one would probably be my favorite because it has all the possible values. It looks a little bit nicer to work. Okay, questions to write down and to circle. 7, 8, 9, and 12. And we're going to start right now and I want you to read 12, and we are going to go over it So section of this course is also to develop your problem-solving skills. So what we learn in class gives us the basic tools to do things, but then math is one of those things that once you have the basic tools, well, there's many connections you can make, and there are complicated complicated questions that still can be asked that are considered fair, but you might not have seen them before. And I feel like number 12 is a problem-solving question in that sense. So number 12, it says, determine where the graph of f of x equals x squared plus x minus 6 intersects the graph of each function below, and how do you know? So this is obviously, we didn't do one like this in our examples. This sounds different, and you can't just go, oh, I remember when we did this in class, you do this, 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 and this. Perfect. This is problem solving in that way. So we have to think about, what does everything that was given to me in the question, what does it mean? What do I know about it? And if I think about all the things that I know about it, maybe the solution will appear. So this is how I would go about problem solving in this one. I'm like, first of all, a good indication that it's a problem solving question is you read it and your brain says, I have no clue. Then you're like, okay, I'm in a problem solving situation. So in a problem solving situation, I ask myself, well, what do I know? I'm like, okay, I've got f of x. It's a parabola. So in my head, I start to just sort of imagine a parabola. I'm not even adding my axes yet because I'm just like, but I know that that parabola goes up from grade 11 because I have a positive x squared. Okay? Then, y equals negative f of x. I know that that is a vertical reflection, which means it's going over the x-axis. So now I have to have an x-axis to flip over. There's a couple of possibilities, right? The x-axis could be like this, down below. If it's down below and I flip it over, will the graphs ever intersect? No. Does that make sense? If it's there, then my flip over would be like here. Do those two graphs intersect? No. Or it could be that my x-axis is moved up like that. If my x-axis is moved up like that, and I did a vertical reflection, it would look like this. And then I would have intersection points there. So this is me problem solving, thinking about the situation, thinking about what everything does, and based on thinking about that, I now have come up with the idea, if they intersect, then it would have to be at the x-intercepts. And my brain would automatically ask myself, how do I find x-intercepts? Is that something I know how to do? Yes. I've done that before. How do you find an x-intercept? Algebraically, you would plug in 0 for y and solve for x. So now I look at my equation, I'm like, well, I don't have the green equation, but I don't need the green equation. I have the blue graph is the equation that's given. I could just plug in 0 for y, and I have x squared plus x minus 6. Is this solvable? Do I know how to solve this from things I've learned in the past? Yes. I learned this in grade 11. I could factor. Factoring this to solve changes it from adding to subtracting to multiplying. It's going to have to be 3 and 2, with the 3 positive and 2 negative. And I find out the x-intercepts are at 2 and negative 3. So from this, I can now write a statement. So you see how the problem-solving strategy works out. You have to say, I have to use everything I know and start writing down information that I know. And then, once I start looking at the information I know, hopefully, some kind of idea comes to me that says, oh, and in this case it was, they would intersect at the x-intercepts. So I don't even need to do a lot of algebra to figure out what I need to look for. And then once I figured out what it is, right? Can you see that you know from grade 11, you might have to take some review, but you know how to graph x squared plus x minus 6. But actually graphing it completely wasn't necessary. I just had a basic idea, and then I found out that they intersected at the x-intercepts. So now we can do the same thought process for part B. Again, I have my new parabola. In part B, it's a horizontal reflection. It's over the y-axis. There's going to be a y-axis somewhere. If I reflect it over the y-axis, it's going to cross at the y-intercept. I ask myself, how do you find a y-intercept? Well, again, I don't need to find it in the green equation because I don't know it, but I could find it in the blue equation. I find a y-intercept by plugging in 0 for x. So I take my blue equation. Probably wouldn't have to write that down. You could probably do that mental math on your own. But it's showing that I plug in 0 for x, and they would intersect at 0 and negative 6. So again, that is an example of problem solving. On all of your tests, there's going to be a problem solving section. Sometimes a problem solving section is technically no longer problem solving, because if I give you this question, you now know how to do it. Is it still problem solving? Maybe not, right? Problem solving technically should be something a little bit new, but if I give you too many new things on the test, then you start to feel like that's, if the whole test was like completely problem solving, you'd be like, that was me. That was hard. Because you'd have to think the whole time. You don't want to have to think the whole time during a test. Some of it when you do a test, it's kind of nice when you go, oh, I know how to do this one, and you do it, and you feel good. So some of your tests majority of your tests will be that. We just learn a lot of things, and so it just becomes hard because we learn so much. But as you're learning stuff, again, your goal is, if you're learning it and it doesn't make sense, you just know how to do it, then you should look at that again and try to get things to the point where you're like, this makes sense to me, because then it's going to be easier when you get to the test. And doing your homework, right, sometimes can help you with those problem solving, because you will get problem solving questions in your homework. And if you ask questions about it, then if that same problem solving one is on your test, you've already gone through it once, and it makes it less scary, and you're able to do it well. So again, I encourage you, make sure that you're doing the questions and the homework as we're going through this course.